During World War II, Germany was famous for its advanced engineering. From precision optics to complex tank transmissions, the phrase German engineering carried an aura of superiority. Yet on battlefields across Europe, an inexpensive American firearm challenged that reputation in a surprising way. It wasn't a sophisticated machine with polished steel and intricate craftsmanship. It was simple, crude even. It cost about $20 to manufacture, but this humble weapon proved that in total war, practicality could defeat perfection. That firearm was the M3 Submachine Gun, nicknamed the Grease Gun. While German forces relied on carefully machined weapons like the MP40, American industry focused on mass production. The result was a gun that lacked elegance but excelled in efficiency. It became a symbol of American industrial might, proof that winning wars depended not only on innovation, but on scale. In muddy foxholes, ruined cities, and frozen forests, the $20 American gun demonstrated that reliability and affordability could neutralize technological pride. German engineering wasn't defeated by something more refined. It was overshadowed by something easier to build, easier to replace, and easier to use. The story of this weapon is not just about firearms. It is about philosophy. It reflects how the United States approached war differently, prioritizing output and function over mechanical beauty. And in the brutal arithmetic of World War II, that approach mattered more than anyone expected. The M3 submachine gun was introduced in 1942 as a replacement for the more expensive Thompson submachine gun. The Thompson, often associated with Prohibition-era gangsters, was powerful and effective but costly. Its detailed machining and high-quality materials made it expensive and slow to produce. In contrast, the M3 was designed with wartime necessity in mind. Engineers stripped away every unnecessary detail. The receiver was stamped from sheet metal. Components were simplified. Even the finish was utilitarian. The cost dropped dramatically, around $20 per unit compared to the Thompson's much higher price. For a nation preparing to arm millions, that difference was enormous. American planners understood that modern war required not thousands of weapons but millions. The M3 fired .45 ACP rounds, the same ammunition used by the Thompson, ensuring logistical continuity. Soldiers quickly realized that while the Grease gun lacked the Thompson's polish, it delivered dependable close-range firepower. In urban fighting and trench assaults, that mattered more than aesthetics. The weapon's simplicity also meant fewer manufacturing bottlenecks. Factories that once produced automobile parts could switch to making M3 components with minimal retooling. This flexibility exemplified American industrial power. The M3 was not glamorous, but it was available in numbers that overwhelmed enemies. And in war, availability can outweigh excellence. German forces entered the war confident in their small arms technology. The MP40 was a well-engineered submachine gun known for its folding stock and smooth recoil. It was comfortable to handle and accurate in controlled bursts. German troops appreciated its reliability. However, it was more complex to manufacture than it appeared. Precision parts required skilled labor and time, two resources that became scarce as the war dragged on. Meanwhile, the United States ramped up production of the M3 at astonishing speed. The contrast highlighted a key strategic difference. Germany valued mechanical refinement. America valued scalable production. As Allied bombers targeted German factories and supply lines, replacing lost weapons became increasingly difficult. American forces, supplied by a vast industrial network largely untouched by bombing, faced no such limitation. The Grease gun's crude appearance concealed its greatest advantage. It could be replaced almost instantly. If damaged, another could be issued without hesitation. German units sometimes found themselves carefully maintaining their equipment because replacements were uncertain. American soldiers, by contrast, had confidence in abundance. This psychological factor mattered. When troops know supplies are secure, morale improves. The M3 symbolized that security. It proved that engineering brilliance alone could not compensate for limited production capacity. In the end, volume reshaped the battlefield balance. One of the M3's most important strengths was reliability under harsh conditions. European battlefields were unforgiving. Mud in France, snow in the Ardennes, dust in Italy. Weapons clogged easily. Complex mechanisms often failed when exposed to dirt and debris. The M3's simple blowback design meant fewer parts to jam. Soldiers appreciated its rugged nature. While it was not perfect, its straightforward construction made field repairs easier. German weapons were dependable, but their tighter tolerances sometimes demanded cleaner conditions. In prolonged campaigns where maintenance resources were stretched thin, simplicity became a survival trait. The M3's slow rate of fire also improved controllability, reducing ammunition waste during chaotic engagements. In close-quarters fighting, particularly during the push after D-Day, American troops relied heavily on submachine guns for clearing buildings and trenches. The grease gun fit that role well. It was compact, powerful at short range, and easy to operate. Its collapsible wire stock made it practical for armored vehicle crews, who needed compact weapons inside tight compartments. Tankers especially valued the M3 for its portability. The German army had similar needs, but replacing lost or damaged equipment grew more difficult over time. As Allied forces advanced deeper into Europe, the sheer number of available American weapons reinforced operational momentum. The $20 gun became an instrument not just of combat, but of sustained pressure. Ultimately, the story of the M3 submachine gun reflects a broader truth about World War II. Victory was not determined solely by which nation built the most technically impressive machines. It depended on which nation could sustain production, adapt quickly, and equip soldiers efficiently. German engineering achieved remarkable feats in tanks, aircraft, and firearms. Yet even the most advanced designs faltered when fuel, spare parts, and replacements ran short. The United States, protected by oceans and fueled by vast industrial capacity, produced weapons at a scale unmatched in history. The M3 symbolized that approach. Cheap, functional, replaceable. It did not render German engineering useless in a literal sense, but it made superiority irrelevant in practical terms. A soldier with a working, available weapon held the advantage over one waiting for a precision-crafted replacement. In the calculus of industrial warfare, cost-effectiveness became a weapon of its own. The $20 American gun demonstrated that war favors systems, not showpieces. While historians often marvel at the complexity of German designs, the grease gun reminds us that simplicity can be equally powerful. It stands as evidence that sometimes the most decisive innovation is not refinement, but reduction. As Allied forces pushed through North Africa and into Europe, the importance of logistics became undeniable. The United States was fighting a global war across multiple continents, and every rifle, tank, and aircraft had to be transported thousands of miles. In that context, the affordability and simplicity of the M3 submachine gun offered enormous strategic value. A cheaper weapon meant more could be produced, shipped, and stored. It also meant that battlefield losses did not cripple supply chains. German industry, under increasing strain from Allied bombing campaigns and material shortages, struggled to maintain output of even its standard-issue weapons like the MP40. The United States, by contrast, benefited from a vast industrial base that could convert automobile factories into arms production centers almost overnight. Companies such as General Motors played a major role in manufacturing components for the M3. This fusion of civilian industry and military necessity represented a new kind of warfare, industrialized conflict on an unprecedented scale. The grease gun's design intentionally reduced the need for skilled machinists. Stamped parts replaced milled ones. Welding replaced intricate assembly. Every decision reflected urgency, and as American troops landed in Italy, France, and later Germany itself, they carried with them not only weapons but the power of an economy operating at full throttle. The M3 may have looked unimpressive, but it was backed by a supply system that dwarfed anything the Axis powers could sustain. Psychology also played a subtle but important role in the grease gun's impact. German forces often took pride in the technical excellence of their equipment. Weapons like the MP40 symbolized discipline and mechanical sophistication. But as the war progressed, German soldiers increasingly encountered American units that seemed endlessly resupplied. Damaged vehicles were replaced. Ammunition was abundant. New weapons appeared without delay. The constant presence of fresh equipment conveyed a message. The United States could afford this war. The M3 submachine gun became part of that message. It was not just a tool, it was evidence of overwhelming production power. In contrast, German troops sometimes faced shortages and had to rely on captured equipment. The disparity highlighted a painful reality. Engineering skill could not compensate for shrinking resources. When soldiers feel supply lines weakening, confidence erodes. American troops, however, grew more confident with each successful operation. The grease gun's very ordinariness reinforced the idea that America did not need perfection to win. It needed persistence and numbers, and those numbers kept growing. In a war where morale mattered as much as firepower, the perception of endless American resources contributed to the erosion of German strategic confidence. The design philosophy behind the M3 reflected lessons learned early in the war. Initial U.S. reliance on the Thompson submachine gun proved effective but expensive. Military planners realized that large-scale conflict demanded cost efficiency. The grease gun's engineers embraced minimalism. Even its nickname came from its resemblance to a mechanic's grease dispenser. It lacked wooden furniture and ornate machining. Instead, it featured a simple metal frame and a crank-style cocking mechanism. While some soldiers criticized its appearance, most valued its practicality. ACP round delivered strong stopping power at close range, ideal for urban fighting and trench assaults. As Allied forces fought through the hedgerows of Normandy and the streets of European towns, short-range engagements became common. In those environments, portability and firepower mattered more than aesthetic refinement. The M3 performed its role effectively. German small arms remained formidable, but they were no longer decisive advantages. The battlefield equalized technological gaps. When both sides possessed automatic weapons, outcomes depended on tactics, coordination, and supply. The grease gun fit seamlessly into combined arms operations supported by artillery, armor, and air power. Its success demonstrated that even a modest firearm could contribute meaningfully to a much larger war machine. Another critical factor was training. The M3's simplicity reduced the time required to train new recruits. With millions of Americans entering military service, efficient instruction became essential. Complex equipment requires longer familiarization. The grease gun's straightforward controls allowed soldiers to become proficient quickly. This efficiency accelerated deployment cycles. German forces, facing manpower shortages by 1944, struggled to train replacements adequately. As experienced troops were lost, maintaining consistent performance became difficult. Meanwhile, American units rotated fresh soldiers into well-supplied formations. The steady flow of equipment, including the M3 submachine gun, ensured that new arrivals were not hindered by shortages. The broader strategic picture reveals a pattern. American industry compensated for inexperience with material abundance. German engineering excelled in craftsmanship, but it could not offset diminishing human and industrial reserves. The grease gun symbolized accessibility. It did not demand expert handling or meticulous care. It was built for citizen soldiers, factory workers, farmers, and students turned infantrymen. This alignment between weapon design and societal structure amplified its effectiveness. The United States mobilized not only its factories, but its entire population. The M3 became a practical extension of that mobilization. By the final years of the war, the industrial imbalance between the Allies and Germany was unmistakable. Allied bombing raids had severely damaged German manufacturing centers. Fuel shortages crippled mobility. Replacement parts became scarce. Under such pressure, even well-designed equipment could not perform consistently. In contrast, American production lines continued operating at immense capacity. The M3 submachine gun remained inexpensive and widely available. It served not only in World War II but continued in U.S. service for decades afterward, a testament to its durable design. German engineering achievements remain respected by historians and collectors. However, the broader lesson of the $20 American gun lies in its strategic context. War is not a competition of isolated machines. It is a contest of systems. The grease gun represented a system optimized for output, replacement, and integration into a massive logistical framework. German engineering was not rendered worthless, but it was overshadowed by scale. When one side can field millions of functional weapons without straining its economy, technological elegance loses its edge. The M3 proved that simplicity, backed by industrial depth, could neutralize mechanical sophistication. In the end, the $20 American gun did more than fire bullets. It embodied the industrial momentum that ultimately carried Allied forces to victory. As Allied forces crossed into Germany in 1945, the industrial imbalance that had been building for years became undeniable. American infantry units advancing alongside tanks and mechanized columns carried practical, standardized equipment, including the M3 Submachine Gun. By this stage of the war, German industry was fragmented and strained. Emergency production measures attempted to simplify weapons manufacturing, but these efforts came too late to reverse the tide. The United States had already perfected mass production techniques